Mr. Sutton here, bringing you the Algebra 2 3-6 Part 2 homework solutions on quadratic inequalities in one variable. For this problem, they want us to solve this quadratic inequality algebraically. So we're going to plot this thing on a number line and then basically write down a solution set that describes what we see. So in order to do all this, we're going to do some sign analysis, and for that we're going to need to find values where this function equals 0. So let me just pretend that this does equal 0, and then just solve this for the roots. So we can factor this one. Two things that multiply to 9 and add up to 10, well, 1 and 9. So we have x plus 1, x plus 9 equals 0. So that gives me the solutions of x equals -1, and then -9 zeros out the other factor. All right, so let's put those on a number line. Now I have to pay attention to the inequality. Because there's no equals in this less than inequality, I'm going to use open dots on -1 and -9. So -9 is going to be over here, and then -1 somewhere over here to the right, not being super precise as long as they're in the same, in the correct order. And now we're going to do a little sign analysis in each of these three different regions that I've split this up into. So I'm going to plug some representative numbers into the factored version of this function here. So let me plug in something that's less than -9, like -10. -10 plus 1 is negative. -10 plus 9 is negative. Negative times a negative is a positive. And then between -9 and -1, -8, -5, -4, take your pick. I'll go with -4. Any of those are fine. So we have a negative if I plug that in there. And then -4 plus 9 is a positive. Negative times a positive is negative. And then after -1, 0 is pretty easy. So we have 0 plus 1 and 0 plus 9 are both positives. So that comes out to a positive times a positive, which is also positive. Now looking at our inequality, it was less than 0 that we were looking for. So we're going to shade the stuff that's in this negative area. And then just writing the inequality that goes with that, we have -9 less than x less than -1. On this problem, we're trying to solve this inequality algebraically. So I'm going to zero this thing out and then maybe factor it. We'll see. So to do that, let me just subtract 25 from both sides. And when I do that, I don't need to worry about the inequality reversing. That's only if I divide or multiply by a negative. So I've got 4x squared minus 25, and I've set this equal to 0 because I'm going to actually figure out the roots for this thing. Now this can be factored. This is a difference of squares, so I can just square root each of these things and use the plus minus parentheses. So the square root of 4x squared is going to be 2x. Square root of 25 is 5, so I have 2x plus 5 and 2x minus 5 equaling 0. Zeroing each of these out and solving them individually, we have 2x plus 5 equals 0, so 2x equals -5, and then x is going to be -5 over 2. For this other one, I can write 2x equals 5 if I add that 5 over there, and then divide by 2 to get x equals 5/2. So let me do my number line, and since I have no equals under the inequality, I'm going to use open dots for both of these. So we've got -5 open dot there, -5/2 rather, and 5 over 2 gets an open dot. Now let me plug in some numbers that are in each of these different three regions here into my factored version of this to see if things are coming out positive or negative. I'm going to do some sign analysis. So something less than -5 over 2. -3 is an easy one, or you could go even more negative, but 3 works here. So we have 2 times -3 plus 5 is going to be negative. 2 times -3 minus 5 is also negative. Negative times a negative is going to be a positive. Now a number between negative and a positive number, 0 is the easiest case there. So we have 2 times 0 plus 5 is positive. 2 times 0 minus 5 is negative. So positive, negative gives us a negative in there. And then finally something bigger than 5/2 like +3. So that's going to give us a positive for this first parentheses. And let's see, 6 minus 5 is also positive. Positive gives me a positive by multiplication. We wanted less than 25 initially, and that became less than 0 after we rearranged things. So we want the negatives, which is this middle region here. And then just writing that inequality, we have negative 5 halves less than x, less than 5 halves. On this one, I'm trying to solve this inequality algebraically. So first thing I'm going to do is find the roots of this thing. And to do that, I'm going to move this 10 over to the left side to zero it out. So we'll have 3x squared minus 13x plus 10, and then I'll just write equals 0. But we just want to kind of keep in the back of our minds that this would have been a greater than 0 had I left the greater than symbol in there. So factoring this thing, going to be a little bit tricky. We could go straight to quadratic formula, but I think this is factorable. Let's try the AC method and see if I can get that to work. So we've got 3 times 10, AC value of 30. And then I'm looking for factors of 30 that add up to negative 13. Well, let me think. 1 times 30, nope. 2 times 15 would work, except they would have to be different signs. Since this is positive 30, they have to have the same sign. So let me keep looking. How about 3 times 10? Yeah, that works if I have negative 3 and negative 10. So let me break up this negative 13 then into a negative 3x and a negative 10x. And at this point I can use grouping to factor this. The first two terms I can take out a 3x, leaving me with x minus 1. For the next two terms I can take out a negative 10, leaves me with x and then minus 1 there as well. So we have x minus 1 coming out of everything, and then 3x minus 10 is my other factor. Setting these equal to 0 in solving, we have x equals 1. And for this next one, I can add the 10 to the other side. And then if 3x equals 10, we have x equals 10/3. So let me put those on a number line. Since there was no equals in this inequality, these are both going to be open dots. So we have an open dot on 1 and also on 10/3, which is like 3.3-ish. Now let me do some sign analysis by plugging some values from each of these regions into the factored version of this inequality. So we've got, let's see, something less than 1. I think 0 is pretty easy. 0 minus 1 is negative. 3 times 0 minus 10, still negative. So that's going to be negative times a negative, which is positive. Next, we have a number between 1 and 10/3. 2 is pretty easy. 2 minus 1 is going to be positive. 3 times 2, or 6, minus 10 is negative. Positive times a negative is a negative. And then something bigger than 10/3, 12/3, or 4, or 5, that would be 15/3. Any of those, something bigger. So we've got 5 minus 1 is positive. 3 times 5 minus 10, still positive. Positive, positive gives me a positive. So initially we had greater than negative 10. That's now greater than 0. So since we have greater than 0, I want to shade the parts that are positive on this number line. So we have all the stuff to the left of 1 and all the stuff to the right of 10/3. Writing out the inequality to describe this, we have x is less than 1 or x is greater than 10/3. For this problem, they want us to solve this inequality by graphing, but this is one where we're allowed to use technology. So let's go to Desmos for this. So on Desmos, I'm just going to graph x squared minus 3x plus 1. So x squared minus 3x plus 1, there we go. Maybe zoom in a little bit. And really all I'm interested in two things. I want to know the x-intercepts, which are like 0.38-ish and 2.62. I'm also interested in whether the parabola is above or below the x-axis, outside and in between these x-intercepts, because that's my sign analysis. So let me just cut and paste that so we can look at it on my PowerPoint screen here. So we notice that we're looking for less than 0 for the inequality, and the parabola is below 0, below the x-axis, in between 0.38 and 2.62. So I'm just going to write for my solution 0.38 less than x less than 2.62. And I'm using less than because that's the inequality that we started with here. If we were to really accurately graph this out by hand, these would be open dots and a dashed line. We're going to solve this inequality by graphing the two-dimensional parabola on Desmos. So let's go to Desmos for that. So we've got x squared minus 4x plus 2. And I see we've got some x-intercepts here at 0.59 and also 3.41. So here's the picture that we just graphed. So we were looking for where x makes this thing greater than 0. That's where the parabola is above the x-axis on the graph that we just sketched here. And that's happening to the left of 0.59 and to the right of 3.41. So for my solution then, I'm going to write x is less than 0.59 or x is greater than 3.41. On this one, we have a rectangular fountain display with a perimeter of 400 feet and an area of at least 9,100 square feet. They want us to describe the possible widths of the fountain. So this is going to be a geometric system of equations kind of deal. We're going to start with a perimeter formula, which in general for a rectangle is 2w plus 2l equals p. And the p-value in this case is the 400 perimeter that they gave us. Next, let's write something to symbolize this other piece of information. They said the area was at least 9,100 square feet. In general, the area of a rectangle is length times width. So we can write LW is, and they said at least, so greater than or equal to 9,100. And this now gives us, I don't want to call it a system of equations, but it's a system of something, inequalities, I guess, or equations that we can solve. So in order to get the possible widths, our end goal here is to eventually end up with an inequality that just has a w in it. So that means at some point along the way, we're going to have to get rid of this L and solve something with a w. To get rid of the L, I'm going to use this equation that we have over here. I need to use the equation for this because if I'm going to substitute something for L, I need an equals. An inequality is not really going to be very useful in that situation. So to get L by itself so that I can get rid of it, I'm going to first subtract 2w from both sides. So 400 minus 2w. And then I can just divide both sides by 2. So I'll have L equals 200 minus w. I can plug in 200 minus w for the L over in this inequality now. So that's going to be 200 minus w in a parentheses times the w that was already there. And now we've got it all in terms of w. So let me just distribute this. I'm going to have to eventually get everything over to one side. So we've got 200w minus w squared. And as one little extra step, let me move this 9100 over to the left side. And I'll just write things in order as well. So we'll have negative w squared plus 200w minus 9,100 greater than equal to 0. This is the expression I'm now going to graph on Desmos. So let me go ahead and start doing that. So here's Desmos. Let me do negative, and I'll write this with an x because Desmos likes x better. So negative x squared plus 200x minus 9100, and I can't see anything, so let me zoom out a bit. Let's see here. Let me zoom out a lot. Oh, there it is. Okay. All right, so just zooming out enough to see which way this parabola is going. It looks like in between those two x-intercepts, the parabola is above the x-axis, and then outside of them, we're below the x-axis. So what are those x-intercepts? So it looks like we've got 70 and 130. All right. So we were looking for values of w that made this thing positive, greater than 0. The parabola is above the x-axis in between 70 and 130. So our solution then, our fountain is going to have possible widths that are 70 less than or equal to W less than or equal to 130. And that's going to be in units of feet.